Hey guys, today we're going to factor polynomials, which is essentially undoing our FOIL method. So we'll have things like this, 3x squared plus 6x minus 3. And we want to take out the greatest common factor. So here we can factor out a 3 from each term. So if we do that, we have 3 parentheses x squared plus 2x minus 1. So we've essentially divided that 3 from each term. Okay. Here's another one, negative 4x cubed minus 10x. We have to find what is the greatest common factor that negative 4x cubed and negative 10x share. Well, we know that they share a negative 2, and then they also share an x. So we're going to divide out that negative 2x, and that leaves us with, negative 4 divided by negative 2 would be a positive 2, and then x cubed divided by x is an x squared. Similarly, negative 10x divided by negative 2x gives us a positive 5. Those are some basic ones. Then we're going to look at factoring a trinomial. So we're going to look at factoring something like this, ax squared plus bx plus c. So there's a couple hints. If this sign in the back is a plus, then that means in both of my parentheses, because like I said before, we're undoing that FOIL method. So our goal is to get back to 2 sets of parentheses. So this plus in the back means that both signs in my parentheses will match this middle sign. If, however, that sign is a minus, then it means that in one parentheses I'll have a plus sign and the other I'll have a minus. We'll do some examples to help make sure that makes a little more sense. But another rule or a hint, the numbers that I choose for my parentheses must multiply to c, but they must also add to bb. So let's get to a couple examples. Here I have x squared plus 5x plus 6. First of all, I have a plus in the back. So I start my 2 parentheses every single time I go to factor a trinomial. This will be my first step. 2 sets of parentheses with an x in the front of both of them. Okay, then this plus sign says both signs will be match this middle sign. So we have both sets of parentheses getting a plus sign. And now we have to think of factors of 6 that add to be 5. So factors of 6 are 1 and 6 and then 2 and 3. And we know that 2 and 3 add to be 5. So I actually did this incorrectly. And I don't have a pen with me. So this should say x plus 2, x plus 3. Okay, so please make a note of that. That should be x plus 2, x plus 3. The reason we can't actually check our work, we could FOIL this. We'd get x squared plus 1x plus 5x plus 5. And that would be x squared plus 6x plus 5. So I got this way wrong. Remember, this should say x plus 3, x plus 2. Let's see if I can get the next example correct. X squared plus 3x minus 10. Okay, so we start with our 2 parentheses. This time there's a minus in the back, so we talked about each parentheses, or we will have a plus in one parentheses and a minus in the other. Okay, now we find what multiplies to 10 that could add or subtract to 3. Well, we have 1 and 10 and 2 and 5. And 2 and 5 do subtract to be 3. So we know that we're going to use 2 and 5 as our 2 numbers to fill in these holes. And then there's another little hint here. Our larger number is always going to go with this middle sign. Okay, so our larger of these 2 factors, so 5 is our larger number, will go with the plus sign. X plus 5 times x minus 2. Again, if you were to check this, you'd get x squared minus 2x plus 5x minus 10. And a minus 2x plus 5x would give you a positive 3. I'd like you guys to factor x squared plus 3x minus 40. Okay, here's another one. X squared minus 10x plus 25. So parentheses, plus sign in the back means both signs will match this middle sign. So we have x minus, x minus. And now we look for what numbers multiply to 25 that also add to 10. Well, 5 and 5 multiply to 25, and they also add to 10. So we have an x minus 5, x minus 5. And we would definitely want to simplify that to be x minus 5 squared. Here's another one, x squared plus 12x plus 36. Our parentheses are going to be x plus because of that plus sign. They match this sign. And then what multiplies to 36 that adds to 12? Well, that'd be 6 and 6. Again, simplify that to be x plus 6 squared for full credit. Here's a little more complicated one, but the same idea. So we have 9x squared plus 30xy plus 25y squared. So with that second variable, our signs are still going to be the same, but this time, instead of just an x in the front, we're also going to have a y in the back, because this is what we get when we multiply our last term. So a y squared comes from a y times y. And then we're looking for what numbers are we going to multiply together to get a 25 and also a 9. So if we look at the patterns that we've had in the last two examples, it's some quantity squared. So we're looking for, can I take a number times itself to get 9, and can I take a number times itself to get 25? And we can. We can take the square root of 9 to get 3 and the square root of 25 to get 5. So here we have 3x plus 5y times 3x plus 5y. And if we were to FOIL and check our work, we would get a 9x squared plus 15xy plus 15xy plus 25y squared. And we know 15xy plus 15xy is what would give us our 30xy. This, however, can be simplified to write 3x plus 5y squared. Two final examples. X squared minus 49 can be simplified to x plus 7 and x minus 7. This is what we call a difference of two squares. We're missing that third term. So the only way to get rid of that third term is to have the middle, the outside and the inside of our FOIL cancel off. So if we were to FOIL this, it'd be x squared minus 7x plus 7x minus 49. And that minus 7x plus 7x is would simplify to be 0. So anytime you have a binomial, see if you can take the square root of that constant, and then it'll be a difference of two squares.